part 2 of the video. What we're doing here is we're carrying on with number 2, and we have to find the modulus and argument for z cubed plus z to the 6. Alright, well, since we're adding complex numbers, we can't use this form here and simply add moduluses. That's not how that works. If you go back to thinking graphically about that, you know that's not going to be true. So what we need to do is use the formula I mentioned earlier on, where we've got x plus I y is equal to r times cosine theta plus I sine theta. Now, and then we can add them together, you see. So I know that for z3, r is 1 cubed. So r is 1 cubed, and so that's the modulus, and theta is going to be 3 times this, which is pi. For this one, r to the 6 will be 1 to the 6, which is 1, and theta will be 6 times this, which is 2 pi, but if you just quickly remind yourself, we're measuring this way, 2 pi takes us right back round there again, so theta is 0. Okay, now we're going to use this. Okay, so z3 will be 1 bracket cosine theta plus, and theta, sorry, in this case, is pi, isn't it? Plus I sine pi, brain work. Okay, plus, and then I'm going to do the same for z, 1 into cosine 0 plus I sine 0. What does this give us? That's minus 1 sine pi. That's I, so that'll be sine pi 1, yep, I think that's 1. Plus, and here we'll have cosine 0 is 1, plus sine 0 is 0. So we end up with 0 plus I. Now if we were to look at this graphically, here's our imaginary axis, here's our real axis, we've got a point here. So what is the modulus? Modulus equals 1, because its length is 1. And the argument is going to be undefined. You might be thinking, what? How's it undefined? Well, remember how we used tan to find our value for theta, and because we don't have an opposite and adjacent here, we've got a 90-degree angle. Well, you know that tan pi over 2 is actually undefined. So we call this one undefined. That's a bit of a weird one. Just thought I'd help by explaining that one to you. Now let's move on. I. Okay, so for I, what have we got for I? We have 1 over z. Now another way of writing this is z to the minus 1, and we can use the rules that we did earlier. So z to the minus 1 will equal 1 to the minus 1, and minus 1 times pi over 3. So the modulus and argument will be as follows. Modulus 1, argument, negative pi over 3. Last one from question 2 is question 2J. For question 2J, we have as follows, 2 minus 2, 2. 2, I think, over z minus 1. Now, you want to write this like this first of all. I think z was 1/2 plus 1/2 square root 3i minus 1, and we can simplify that. That becomes 2 over minus 1 plus half square root 3i. And then we're going to use what we learned earlier to change this. We're going to times by the conjugate, complex conjugate. Okay, and when we do that, you can do the working out yourselves, but on the top you'll get minus 1, I think, minus 1, and then minus square root 3i, and on the bottom you will get 1/4 minus 1/4 times 3i squared, and this will give us minus 1 minus square root 3i. Okay, so that's that one. Now we need to find the modulus and argument. So let's just do a quick drawing. Minus 1 minus square root 3i, so it'll be like this. Modulus equals minus 1 squared plus minus square root 3 squared, and then we take the square root of that. Well, that's 3, that's 1, that's 4, so it's square root 4, which is 2. The argument. Now this is a little bit more tricky. If we have a triangle here, or a triangle here, let's say we want to find this theta here. Theta equals the inverse tan of the opposite, which is the down, so it's minus square root 3, over the across, adjacent, which is minus 1. Now if you pop that into your calculator, you're going to get pi over 3. So this angle is pi over 3, but remember when we're giving modulus in argument form, we start here and measure around. So that must be, therefore, the argument must be minus 2 pi over 3, and you might be wondering, why is it minus 2 pi over 3? Well, if we're going this way, it's minus. If we're going this way, it's positive. Okay, and there we go. That is question 2 done. Okay, well, let's move on. The next one that I've elected to do is question 4a. Now, with question 4a, we are given this information. The modulus of z is equal to 2, and the argument of z is equal to pi over 2, and we are being asked at this point to convert it to, we want to put it into x plus iy form. Well, to do this, all we need to do is what I did in the previous question. We're going to go r into cosine theta plus I sine theta. So in this case, r is 2, theta is this, so cosine pi over 2 plus I sine pi over 2. Now, what is cosine pi over 2? I think that's 0, so we should have 2 times 0 is 0. Sine pi over 2 is 1, so we should have 2 times I, or 2i. So that is our first one. I'll do one more of these so you get the hang of them. Let's now look at f. So 4f. 4f, what information do we have? This time I've got the modulus of z is equal to 1/2. And I've got the argument in this case for z is equal to minus pi over 2. Okay, so we're going to use the same strategy. R, which is 1/2, into cosine minus pi over 2 plus I sine minus pi over 2. Okay, now what does this give us? Well, when we expand this, we're going to have 1/2. Now, what's cosine minus pi over 2? I think it's 0 again, isn't it? I think. Let's just check that. Cosine minus pi over 2 is 0. Yeah, so half times 0 is 0. And this one should be minus 1. So we're going to have minus 1/2 I. And that would be turning this from polar form into Cartesian form. Okie dokie. Well, we're going to move now on to number 6. So what do we have for number 6? In number 6, we have z is equal to 1 plus I, and we have w is equal to 1 minus square root 3i. In part A, we have to find wz. Now, this is where we use that information that we learned earlier when we were multiplying. We can, if we have the arguments and the modulus, that's much easier. So I'm going to go modulus of this one. It's going to be 1 squared times 1 squared square root. So that should be square root 2. And the argument is going to be inverse tan of 1 over 1. And the inverse tan of 1 over 1 should be pi over 4, I think, isn't it? Yeah, pi over 4. Let's do the same with this one. The modulus for w is going to be 1 squared plus minus square root 3 squared, which is 3. So 3 plus 1, 4, and we take the square root of that, which is 2. Okay, and then the argument, we're just going to go our opposite. If we quickly to sketch this, we're going across 1 and down here, and we want to know this here. So our opposite is going to be tan, an inverse tan of this here, which happens to be minus square root 3, and then over 1. What does this give us? I'm getting minus pi over 3. Okay, so there we go. That's that one. Now, what is wz going to be? Alright, wz. So we use our rule. It's r1 times r2, which is 2, square root 2. And then we add these. So, pi over 4 minus pi over 3, and that gives us, chuck that in your calculator or do it in your head, is a minus pi over 12, isn't it? Okay. And so the modulus is 2 square root 2, and the argument is minus pi over 12. Okay, team, so we're working on number 6C, and this time we've been told, okay, this one here, we want to find IZ. Okay, so what do we know? Well, Z is here, so if I multiply this by I, I'm going to get I times 1 plus I times I squared, which is I times I, which is I squared, which we could say is minus 1 plus I. Okay, so just the conjugate there. Yes, no it's not, sorry, my apologies. Okay, so we've got that, now we've got to find the modulus. Alright, so is that what we're being asked to do? I think that's what we're being asked to do. Yep, modulus and argument. Okay, so modulus is going to be minus 1 squared plus 1 squared, and so we're going to have square root 2 in this case, and then the argument will be, if you quickly look at a sketch of that, it's minus 1 plus 1, so we've got this sort of scenario here, so it's going to be the inverse tan of, what have we got there, minus 1, positive 1 over minus 1, which is minus 1 anyway. Okay, what does this give us? It's negative, inverse tan, negative 1 is negative pi over 4. Now, be careful here, because I hope you can see that this angle here is not negative pi over 4. Okay? So this angle here is pi over 4. To find the angle that you want, the argument, remembering you're measuring this way, so this must be therefore 3 pi over 4 is your argument. Okay, it's given you that there. Alright, I hope that makes sense. Let's move on. We have 7D is the next one I would like to look at. 7D. So in 7D we are given some exponential form information e to the power of pi I, and I have to be able to explain what is, I need to write it in this form here, x plus iy, Cartesian form. Well, if you go back to what we learned earlier, this here is r, and this here is your argument. Okay, so in that case, I can convert it into this form using the formula r cosine theta plus I sine theta. Okay, and in this case it's going to be, there's a 1 there, right? So it's 1 into cosine pi plus I sine pi, and cosine pi I think is minus 1, so it's minus 1 plus, and then sine pi is 0, so this will be plus 0i, so we would write it minus 1 plus 0i, or minus 1, but maybe we'll just put that in so we've got it in Cartesian form. Alright, we're going to try another one of these. This time we are trying 7b. So for 7b, I have got e to the power of negative pi I over 2i. Okay, same deal again. R is 1, and then this is theta. This is my argument. Okay, so I'm going to go 1 into cosine negative pi over 2 plus I into sine negative pi over 2, and there we go. What have we got here? Negative pi over 2 for cosine, that's giving me a 0, so I'm going to have is equal to 0, and then negative sine pi over 2 is a negative 1, negative 1 times 1, so this will be negative I, so that's negative 1, negative 1i times 1 is just negative I, and that's in Cartesian form. Alright, so for number 8, we're converting this, which is in Cartesian form, into exponential form. So obviously we need to find r, and we need to find the argument theta. So we've got, for the modulus, or r, we know that it's equal to the square root of 1 squared plus the coefficient of I, which is also 1, and that gives us square root 2. And to find the argument, we know that we are dealing with the inverse tan of 1 over 1. I'll just do a quick sketch. I would always suggest doing a quick sketch just to find out where you are in the diagram, so you can see if your answer makes sense. So I'm looking at this angle here. Now when I do inverse tan of 1, I should be getting pi over 4, I think, isn't it? Yeah, pi over 4, and that makes sense. That is right, okay? Pi over 4. And so to express this, this as this, I would then write r, which is square root 2, e, and then pi over 4, I, or I pi over 4, either is fine. Okay, I'll just do one more of those and then I'll leave you to it, and you can ask your questions if you have any issues. So this time why did I rub that off? I'm trying to convert square root 2 minus square root 2i, and I'm trying to convert it into r e theta, e to the theta I. Now, same deal. I'm going to find r. R is equal to the square root of square root 2 squared plus minus square root 2 squared. Now, 2, square root 4, 2. Okay, argument. And we're going to go, oh, there's some nice music in the background. We're going to go square root, let's draw it. We've got square root 2 here, and we're going down here. So this is minus square root 2 for that side, and this is square root 2 here. So I'm going to go opposite, because I'm wanting theta here. Opposite, which is minus square root 2 over square root 2. Okay, and if I chuck that into my calculator, well, that's just going to be minus 1, isn't it? So inverse tan minus 1, it should be negative pi over 4. It is negative pi over 4. Wait a second, have I done that correctly? Yeah. I think I've actually written the question wrong. Negative pi over 4 would be my argument. However, I've just looked at the question again and I realise that there's a minus here. So that's not going to affect this. It's not going to affect that, but it will affect this. I'm going to have a negative here. Now if I pop that in, I will get a positive pi over 4, but I'm just going to sketch it again and I'll show you why I'm going to sketch it. I will end up with something over here, correct? It'll be minus square root 2 down and minus square root 2 back. And when I do theta, I will be getting this angle here. So I will get pi over 4 for that angle there. However, this I've got to start measuring from here. So what I really want is to find this here. Well, if this is pi over 4 and this whole thing is pi, then my argument must be 3 pi over 4. But since I'm going this way, it's a negative 3 pi over 4. We get positive this way, negative this way. So therefore I could write this in exponential form by writing 2 e and then theta to the minus 3 pi 4 over 4i. And that would be my final answer there. Well, I'll leave you to get on with the rest of the exercise. Please hit me up with some questions if you're stuck on any particular ones, and I'll see if I can help you. Good luck, try and get this done, and we really need to motor on and finish this chapter off next week on Monday so that we can get into revision. Alright, good luck guys.